When you live in a tiny, cramped apartment, there's always that one piece of furniture that just ruins the layout, like a giant clunky sofa.
Right. You just spend your whole time working around it,
Yeah,
compromising on space just to make the room function at all.
exactly. And for over a century of car design, well, the internal combustion engine has basically been that giant sofa. But in today's deep dive, we're looking at what happens when engineers finally figure out how to, completely rearrange the apartment.
It really is a massive shift.
Yeah, our mission today is to unpack the engineering secrets that are finally making electric vehicles affordable, safe, and surprisingly spacious. We've got a great stack of sources for this: a Volkswagen media release on their upcoming 2026 ID, Polo and SK Innovation deep dive on battery tech, and an Italian automotive analysis.
And they all point to this really fundamental change in how cars are physically built. We're seeing car makers physically alter layouts to hit that critical 25,000 euro entry-level price point.
Right, and the ID Apollo is like the perfect case study here. So let's unpack this. VW is shifting to the MEB Plus platform, which puts the motor up front.
hmm
Now, since almost every modern gas car is already front-wheel drive, I guess that might not sound super revolutionary to you listening.
Well, yeah, but EVs usually put the motor on the rear axle, or they use a dual motor setup.
Hmm.
By moving everything to the front on this new platform, they aren't just changing the driving dynamics.
What else are they changing then?
They're bundling the motor and the power electronics together up front. And that drastically shrinks the high voltage cable runs through the car.
Oh, so shorter cables mean less weight.
Exactly. Less weight and significantly lower manufacturing costs.
And here's where it gets really interesting for you, the driver, because pulling that motor off the rear axle, it completely hollows out the back of the car.
The space games are wild.
I mean, we're talking about a compact city car that is only 4 meters long, but somehow it boasts a 435-liter trunk. That is huge.
It is huge. But freeing up that trunk space by relocating the motor, well, it actually wasn't enough to hit their cost and range targets.
Wait, really? They needed more.
Yeah, they did. To really get the price down to that 25,000 euro mark, they had to completely gut the inside of the battery itself. That is where we get into cell-to-pack or CTP.
Okay, I have to push back here for a second,
Yeah.
because stripping out the internal battery architecture sounds, well, risky.
How so?
Traditionally, battery cells are grouped into modules, right? Like these protective metal boxes. And then those boxes get wired into the main pack.
That's the standard way, yes.
So if you eliminate those module boxes entirely and just cram raw cells skin to save space, aren't we sacrificing the car's structural integrity?
It sounds like it, but skipping that middleman of the module housing is actually what makes CDP so brilliant.
Okay, I'm listening.
By removing the module step, factory robots no longer have to wire individual cells into small boxes and then wire those boxes into a larger pack.
They just skip a step.
Yeah, they just drop the cells directly into the chassis in one step. It absolutely slashes assembly labor.
Ah, I see. So you strip out the heavy scaffolding, and suddenly you reclaim, what, 20 to 30% of the space inside the battery pack itself.
Right, which means you can pack in way more energy without making the battery physically larger. That is how VW can offer two totally different battery options in the exact same footprint.
Making it totally customizable for how you actually drive. So, like, they offer a cheaper 37 kilowatt hour LFP or lithium iron phosphate battery.
Using abundant materials to keep costs down for city driving.
Yeah. And then there's the denser 52 kilowatt hour NMC battery, which uses nickel, manganese, and cobalt.
And that packs in way more energy for longer highway trips, up to about 450 kilometers.
Wow. So stripping out those complex module structures is what finally helps push manufacturing costs down toward that magic $100 per kilowatt hour threshold.
Exactly, which makes EVs truly competitive.
I understand the cost and labor savings, sure, but my safety question still stands.
Right, the thermal runaway issue.
Yeah. If you pack all these raw cells tight against each other, without those protective boxes, wouldn't one overheating cell just ignite the whole pack like a box of matches?
Well, to prevent that, companies like SK On are using pouch-type cells. This means the cells are packaged in flexible foil rather than rigid metal cylinders.
Okay, flexible foil.
Then, instead of relying on bulky thermal insulation, they slip large surface aluminum cooling plates directly between these pouches.
Oh, I get it. It is like the battery pack traded a heavy suit of external armor for an internal aluminum skeleton.
That is a great way to put it. Those plates are simultaneously chilling the cells and holding the entire car together.
Doing double duty.
Exactly. They rapidly absorb and dissipate heat to prevent that chain reaction, the thermal propagation. And their rigid structure provides the physical integrity you were worried about losing.
Okay, so what does this all mean for you, the listener? When you look at all these advancements, this incredible efficiency in tech, it really starts to make the old combustion engine feel, well, totally anachronistic.
It really does feel a bit like yesterday's technology when you see how integrated and modern this is.
Yeah, we really are moving toward a future where embracing this tech just makes more sense. This engineering shift means your next compact car won't just be cleaner and cheaper to buy and run. It is going to be incredibly smart and surprisingly cavernous inside.
Right. Maximizing efficiency doesn't have to mean compromising on space or safety.
No, it doesn't. But it does leave us with a final provocative thought to mull over before we wrap up today's deep dive.
Let's hear it.
If next generation cars are essentially built directly around these fully integrated, module free cell to pack batteries, how will that change the way we repair or recycle vehicles a decade from now?